Hello everyone. This is a video lecture for College Algebra Math 1314 Section 2.2. More stuff. There's a whole lot of different stuff in this section, so we'll be just seeing a lot of different topics all at once. So the first problem is talking about increasing, decreasing, and constant. And so we need to know the concepts in order to do increasing, decreasing, constant. First off, we're always going to be reading left to right. Left to right, this way. The way you read English is the way you read math. Also, whenever they're talking about increasing, decreasing, constant, it's always going to be x values. Kind of like a mini domain kind of thing. And one last little trick is that we're going to always use the parentheses, never the square braces. And the reason why is because at a particular point, you're not technically increasing or decreasing. You have to have multiple points for the motion to do stuff. And we'll talk about how the minimums and maximums work with that as well, because at the top or a bottom, you don't technically increase or decrease. You're just kind of sitting there. Anyways, so with these three little constraints out of the way, we're going to read left to right, okay? And I want to know, when is it increasing? And so we're actually going this way here, increasing. I know there's an arrow here. Ignore the arrow. From left to right, we're going up, okay? And so I want to be able to write down these answers. I don't think I have enough room up there. So increasing, we're actually going to be increasing from negative infinity up until, and it looks like it's going to be a 1. And then you always use parentheses. And again, that's always x values. Now, you might be thinking negative infinity because it's way down here. No. All this way over here, this is negative infinity. And again, this is going to be a positive infinity. So keep that in mind as we keep going. All right. We're also increasing here from, it seems like 3 up until 5. So we're increasing right there as well. So what I'm going to do is comma 3 to 5. Later, we're going to be using unions. But right now, the program wants you to use commas. So that's just what we're going to do. And that's it. You're actually done with increasing. So now let's talk about decreasing. It's decreasing now. We have here going down, decreasing from that 1 until the 3, comma, and then we're also decreasing all the way right here. And so that's going to be from 5 until, well, it's going down, down, down. And so that's good. Negative infinity? No. Because we're always looking at x values, we're going this way to positive infinity land. Yes, I know we're going down. I just said it. But we're wanting to use positive infinity for my x values. We're going all the way to the right. That just basically means all the way to the right. All right. Are we constant anywhere? Is it anywhere just flat, a flat line? No. So you just don't do it. You just click none, basically. All right. And then the last one. So we got a minimum. And so minimums are going to be bottom of the valleys. Something like this guy right here. And that's very simple. Now you might be thinking, well, there's a more negative number there, and 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 there. Well, yeah, but where are you going to, stop, basically? And so they do actually put a little bit of a wording constraint here. They're looking for relative mins and maxes, okay? And what that means is just it's the lowest or the highest in its neighborhood. And that's an actual math term, neighborhood. So that 3 is the lowest in its neighborhood. And so that's what we're going to look for the minimum. Okay, so the x value for that would be at 3. But the y value is at, here, I guess it's trying to make it there, -1. There you go. And the program's going to be a little confusing on the words and how it all describes it. But really, that's the procedure there. The first box is going to be the x, and the second box is going to be the y. So don't get too confused. It should be fine. Let's keep going. So relative maximum, and then another, again, the maximum value. And so maximums are going to be top of the hills, again, in its neighborhood. So we got right there and right there. So those are both maximums. Cool. So my x values, I got 2 of them at 1 and at 5. So what about the y value? Well, it's at 2 technically, 2 height. So I put 2 because they're both the same. Or do I put 2 comma 2 because there's 2 separate answers? just put the 2. I think the 2 comma 2 still works, but it's repeated. You don't need to repeat it. There you go. All right, so there we go. Let's go on to another graphing problem, kind of similar to that. So I'm only going to do the increase and decreasing constant here. Notice that increasing, going up, well, we're not. It's going constant, and then it's decreasing. So it's never increasing. So what do? You click none. Decreasing, you're decreasing right up here. Is it from 2 and then a negative infinity? No, no, and no. You're looking at x values. That is a 3. And so you're going to go from 3 to positive infinity because it's always going to the right side. Okay? You're going to the right side. Where is that in mathy land? Positive infinity. I know it's going down. We just said it was going down. That's not my point. X values only. Okay, so that's good. For the range, I'm sorry, not for the range, because we were talking about domains, I just thought range. For my constant, we have it all flat right here. And again, where are we starting? Well, basically negative infinity up until the 3 again. So negative infinity all the way to 3, and that's it. Always use parentheses. Because at this point right here, is that increasing? Is that decreasing? Is that point right there, that 1 point, just a point? Is that constant? Is that anything? It's nothing. It's just a point. You can't use any of these terms for that point. And so there you go. A lot of folks I've seen put the 2 as an answer. That is definitely not what you're supposed to do. Again, always x values for all of this stuff, okay? All right. Keep on cruising. And so these are some of my favorite problems, even, odd, or neither. I think they're very simple, so let's go through some of this. I'm just going to have you look at this for a second here. What do you think? Even, odd, or neither? Even. Very good. What about this one? Even, odd, or neither? Odd. How did you know? And then I got a 2 and a 3, even, odd, or neither? That's going to be a neither. So how did you do that? What were you doing? Well, you were looking at the powers, and that is okay. You're going to look at the powers. Now, because this is a little funny, I want to do some more examples with you and see if you're catching on, okay? What about a 3x squared minus 5x to the 4, even, odd, or neither? Notice that my powers are still even though everything else looks weird. That is an even. Very good. Okay. Let's do something a little bit crazy. Let's say we got x cubed minus x, even, odd, or neither. It's odd, not just because of the 3. There's a 1 right here. 3 and a 1. And so those are both odd, so we're good to go. Here's another one. What about 99 x squared plus 7? Even, odd, or neither? And so this one's a tricky one. Notice that how many x's do I have right here? 0 x's. Looking at the powers, they're both even powers. So that's an interesting one. Yes, 0 is even. I'm just going to tell you that right now. And finally, we have, I'm just going to make something up here, 100x squared. Let's make it a cube. And then minus that 1,000, just because. And so we have an odd right here, but notice this 0 would make it even. You can't have both an odd and an even in the same problem, and therefore you type neither. There's your answer for that one. And there's, of course, other variations. There's a real formula for all this, and so f of negative x is equal to f of x. That's even. And if you got f of negative x is equal to negative f of x, that's odd. And if you get anything else, it's neither. I don't like these formulas personally, but they do work. And if you're a formula person, go ahead, have fun with that. Otherwise, just look at the powers. Next question. So we got now the even, odd, or neither, but for graphs. And so even, another name for it, is y-axis symmetry, and for odd, it's origin symmetry, and neither is neither. So notice here, it looks symmetric along the y-axis, and so it is even, and they're going to ask, what kind of symmetry? And you're going to say y-axis symmetry. It's kind of like your face. You have, you got your two eyes and your nose, and well, I guess your nose would have to be on the other side too. That's just how the symmetry is. Y-axis symmetry is even. So this guy right here, I'm going to tell you it's odd. Odd because there's origin symmetry. And so, again, origin symmetry, and let's talk about why it's origin symmetry. Origin is right there in the middle, and there's a symmetry involved because what I'm going to do is tick it over like a clock. So tick, 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 and eventually it's actually on top of one another. They're the same thing, right? So if you could tick this thing over and eventually reach the same thing, then it's odd. It's origin symmetry. And that's it. So if it doesn't look like that, then it's neither. And I'll just give you an example of neither. Let's say that we have a W over here, even odd or neither. Well, is it symmetric along the y-axis? Do we have another W over here? No. So it's not even. If I took here on the center, if I took this blank and I ticked it over here, would I have a blank over there? No. So it's not odd, and so you're just going to have to click neither. It's a lot easier than what I'm making it out to be, of course, because neither, it just doesn't look right. We're all very familiar with even. Y-axis symmetry, odd is not too bad because it's like a clock, and then anything else at all is just neither. All right, piecewise functions. So we're going to talk about first plugging them in, and then the next problem is going to be about graphing them. This is not too hard. Piecewise just means there's two separate mini functions in a bigger function, and they have their constraints here on the side. So like what x's apply. And so we're going to start here with the -1. So x is -1. So is -1 less than 0? Yes. We're going to use this function to plug it in. 4 times the -1 plus the 3. So we get a -1 is my final answer. Okay. Next color. So I got x is equal to 0. Is 0 less than 0? No. Is 0 greater than or equal to 0? Yes, because the equal sign, it applies here to this one. 3 times 0 plus the 7. 3 times anything is 0 plus 7 is 7. And then finally, we're going to use the red. So x is 3. Is 3 less than 0? No. Is 3 greater than or equal to 0? Yes. This one applies. So 3 times 3 plus the 7. 9 plus 7 is 16. And there you go. And I didn't even have to use a calculator. All right. So that wasn't too bad. Now let's graph some piecewise. So this is a little bit more difficult. And honestly, for this class and everything about it, I would recommend using a graphing calculator. And by graphing calculator, I mean Desmos. Desmos.com. You go to the graphing calculator. It's very simple to use. Now, you can't make it look just like this. You have to go and do some kind of fanciness to make it actual piecewise. But you could just graph each of these individually and see it on the left side or the right side. And what I want to do is actually use colors for this. So let's, real quick, I'm going to graph this on by hand. So we got two different sides. We got the left side and we got the right side. And on the left side, we got this negative 3x. We haven't really gone into the, I guess, the section on how to graph these lines yet. For now, I'm just recommending using Desmos to kind of help you. And so what would this actually look like? Let me just get the red color again. So we got a negative slope, and so it's actually going to look something kind of like this here. So that's your full line, okay? That's your 3x, but again, it's only on the left side. So I'm going to just basically erase that side, okay? Now let me use a different color for the blue. So blue, now we're talking about this guy. We're going to be on the right side now, the right side. And so, again, 3x, just as the line, looks something kind of like this, but it's only on the right side. And so I'm going to erase that other side there. That's your final answer. A, B, C, or D, multiple choice, you click it, and you're done. But again, I really recommend going to Desmos and graphing there. It's so much easier on how to do this kind of thing. I wanted to put this one in because it's a commonly missed question. It's kind of a little weird. And so, again, graphing this on Desmos would be very simple. But again, let's go through the procedure on how to do this, even by hand. -2 seems to be kind of like the cutoff line now. That's my border between the left side and the right side. So the right side includes all the stuff over here. So this is all the right side, and that's the left side. Okay, so on the left side, I'm going to go ahead and put right over here as well. On the left side is a +6, and that's actually just going to be a flat line. And again, left side, +6. So 1, 2, 3, 4, 5, 6. I just needed a height, and left side is where you're going to see that line like that. Okay. Now for the right side, it's going to be -6. Again, anything more than over here on the right side. So here we go, 1, 2, 3, 4, 5, 6. And then we got a big line right there. So that's A, B, C, or D, pretty much it. But we're going to have to go a little bit further. Notice that we have here an equal sign. So there's a solid here. The equals means there's going to be a solid. And then there's not one here for this guy. So you're going to have an open circle for that one. And that's the full and final graph that you're going to have to do. Again, multiple choice, A, B, C, or D, and you're done. So I didn't actually have an actual one for number 7, but I got to say that there's other kind of graphs on your homework that are just going to be strange. And so I would really recommend going to Desmos straight up the very first time. I remember seeing some absolute value stuff, and I'm just trying to remember exactly what it looked like. Something like that, maybe. And they say, what's the graph of this thing? And it's multiple choice. Go to Desmos, type that thing in. Another one that I remember seeing was like x to the 4/5 power. I have no clue what that looks like. Go to Desmos, graph it. And that way you don't have to worry about all the stuff. They got a couple other questions associated with these kind of things about increasing, decreasing, and constant, but we already talked about that topic, so I just wanted to remind you about it here that, you'll see it, but it's not too bad. The main thing, use Desmos to graph it immediately. Don't try to do it by hand. This stuff would take forever. And that's all I got. So, thank you very much, and have a great day.